Today we're going to talk about average atomic mass, which is exactly what it sounds like. The average mass of an atom of a given element. So the formula that we're going to use is that the average atomic mass is equal to the abundance, which is the percentage represented as a decimal of that isotope, times the mass of that isotope, plus the abundance of another isotope times the mass of that isotope. And if there's more than two, you just keep going and extending this equation. So there's really two types of problems you're going to have to do. And one would be to simply calculate the average atomic mass, which is pretty easy. And the other would be to calculate the percent abundance of an isotope for a given element. So in this problem, you're just determining the average atomic mass. I tell you 75.53% of all chlorine is chlorine 35. And I give you the mass of that. And then the rest of it is 37. So you can figure out the percentage would be 24.47%, and I give you the mass. So when you plug these values in, that converted to a decimal is 0.7553 times the mass of that isotope plus the abundance times the other mass. When you do that out, you get 35.45, which is the average atomic mass of chlorine. Now, sometimes in these problems, you're not going to be given these masses, and that's fine. If they don't, it actually just makes the math a lot easier because you would just assume this mass is 35 and this mass is 37. But sometimes you'll be given more detail. Use the greater detail when it's presented. Now, you might be wondering to yourself, well, I learned that a proton is 1.007 atomic mass units and a neutron is 1.009. If the mass number is 35, shouldn't the mass be more than that? And you'd be right. If you added up the components, so 17 times the mass of a proton, 18 times the mass of a neutron, then you'd have atomic mass of 35.281 AMUs. But what actually happens during the formation of a nucleus is some of the matter actually gets converted to energy. And you could do that equation if you'd like, using Einstein's equation equals mc squared. I'm not going to make you do it, but you could. You just have to convert mass to kilograms for an atom, and speed of light is 3.00 times 10 to the 8th meters per second. The other type of problem you could have to do is, I could tell you, like copper comes in two isotopes, 63 and 65, and I give you their masses. And I tell you the average atomic mass, you have to calculate the abundance of each type. So, we would use X to represent the variable we're looking for. We'll use that to represent copper 63. So once we know that as a decimal, we can convert it to a percentage, and that will give us a percentage. So X times 62.93 plus, and we're going to use 1 minus X because the whole fraction minus the portion that's copper 63 will be the copper 65. Multiply that by the mass, and then we just combine like terms. You can just see this here and copy it down. And when we solve for X, we get 0.69, which means that 69% of the copper is copper 63, and 31% is copper 65.